Well, hello everyone. Thank you for attending today's webinar on our new Proline Promag W800. So I appreciate the time there. So this is our new battery-powered IoT connected flow meter. So we're really excited to share this new development with you. On the right-hand side there, you will have seen a link to the Smart Blue app, which is an integral part of the W800. So don't worry if you haven't had a chance to download that and have a bit of a play. There's a link later on, and we'll go through a bit more further detail on what that's all about and how you can use that for sure. Sorry about that. So just a bit of housekeeping in case you haven't used the GoToWebinar interface before. So you've got the ability to change your screen size just with the arrow. You can change the size of my head if you like, and then also the size of the screen. And then on the right-hand side there on the dock, there's a handout section where you can do a download of some further information. And then there's also a section there for questions, and we welcome the questions as we go throughout this seminar today, and then we can try and address those a little bit later on. So, and just by way of introduction, I'm Scott Allen, so I'm the industry manager for water and wastewater. Been in the role for only a short period of time, but been with Endress+Hauser for about 3.5 years now, and spent many years in the water and wastewater industry with instrumentation. So look forward to presenting today's information on the W800. Just hand over to Taylor.
Thanks, Scott. I'm Taylor McCurtage. I'm based in the Sydney office, and I'm the industry manager for mining and oil and gas here at Endress+Hauser, Australia. I've been in the role for about 4 years now, and previously come from a process engineering background with a large mining company. I hand back over to Scott.
Thanks, Taylor. So just a bit of a brief overview here of what we're going to cover today with the W800, the new flow meter. So just a bit of a background on the evolution of the Endress+Hauser flow portfolio over the years, and then the next part will be what we're here for, is an overview of the W800 battery-powered flow meter. We're going to cover off a bit of the Bluetooth functionality that's available for commissioning and programming, talk about a bit of verification and how that's completed on the W800 flow meter. We'll go into a few use cases of connectivity, so wireless connectivity with the Promag W800 and what's possible. Then we'll finish off with a few applications in both water and wastewater and mining industries, and then attend to those questions at the end there. So it's a bit of a brief overview. So before we get into the crux of it, I'd like to conduct this quick little poll, and this will just give us a bit of feedback as to what you may be thinking and your experiences with electromagnetic flow metering there. So if you'd be so kind to answer a little poll there for us. So basically, what are important features of a battery-powered electromagnetic flow meter for you? And then if you can answer a little question there, that'd be fantastic, and give us a bit of feedback on your thoughts. I'll give you a few seconds to complete that one. How are we going there, Taylor?
Might give a few more seconds. We've got 2/3 of everyone that's voted so far.
Perfect.
You can select multiple options with this one. All right, I think that's about it, 3/4 now. So I'll close the poll.
Interesting results. Yeah, it's in line with what of the thinking that we have, I guess, in the development of the W800 and the connection and the communication aspect for commissioning. So yeah, I appreciate the feedback's actually interesting results there. And obviously meter verification is another key topic that we're going to cover as well. So I appreciate that. Thanks for that, Taylor. So yeah, just a bit of background on Endress+Hauser from the flow perspective. So we haven't just been doing flow, in the last couple of years. So our history dates back to 1977. So a very, very big history there with flow meter manufacture and supply. So the first iteration of the Proline series is in 1991 there, and then we had Proline 2 in 1999, and then Proline 3 in 2012. So yeah, been doing flow for a long time. Some really big developments over the last couple of years. So last year was if you've seen the previous webinars and alike, the Promag 0DN. So our our full bore flow meter for 0DN applications, where you can install them straight after a an obstruction, so like a right angle bend and the like. So this was a nice release, pretty revolutionary. And then when we walk into 2021, we've already had the Proline W10. My slide will work here or not. We're just frozen a bit there. Here we go. The W10 was released early in the year, which was a whole new transmitter platform. And again, there's a webinar series on this if you're interested in this portfolio. And then today, which is why we're here, the Promag W800. So yeah, very background in flow metering at Endress+Hauser. And then from a production center perspective, a factory perspective, so India, Switzerland, and France are the major factories for us, depending on the product that's being looked at. So just to give you a bit of a background there from Endress+Hauser and the history that we've had with flow metering. So battery powered electromagnetic flow meters, it's not something new, as you all know. It's we've had these sort of meters in the market for a long time, and they're a great solution for those remote applications with no power, and then no wired communications capability. So there's certainly great advantages with the technology that's out there. The complete maintenance free. So being a full bore sort of style of flow meter, we don't have moving parts. We don't, if you relate that back to a mechanical meter, we don't have any turbines or any sort of stuff. So you don't have moving parts. These days, operations completely wireless, non-contact. So you don't have to open housings and things like this. And certainly we have long battery life. So the time between maintenance intervals for battery replacement is can be quite a long time, up to 15 years, depending on the application. There's varied power supply options there, be it internal or external batteries. We've got mains power with battery backup, and then there's also solar arrangements there as well. So very flexible power arrangements for those remote applications. Connectivity, you go everything from basic pulse Modbus outputs to then looking at wireless IoT solutions, and we'll cover that off a little bit further on later on. And from an installation perspective, they can be used above ground, buried below ground, in pits where they're going to be drowned in water. So very varied applications there as well. And then these days, 0DN, so being able to, if you've got space restrictions and you don't have the amount of straight pipe before or after the flow meter, there's solutions now for those applications as well. So, but when saying all that, there's certainly, certainly some challenges with battery-powered flow metering, and one of those can be measurement accuracy, depending on the application. So, I guess in the way these flow meters work, they're not sampling at the same rate or measuring at the same rate as what a powered flow meter does. So, an example, a powered flow meter will take a measurement, 6 times a second. As standard, a battery-powered flow meter is once every 15 seconds. So, if we have flows where you might have fluctuation in those flows, and you're only sampling every 15 seconds, then there's potential to miss those fluctuating flow rates, and then which can cause inaccuracy. So we have some availability there and some functionality that I can share with you later on how we can potentially overcome that. And I guess being an electromagnetic flow meter, one of the aspects that can affect accuracy too is flow velocity. So we need a certain flow velocity for accurate measurement and repeatable measurement. So that's another factor that you keep in mind with your flow metering. So rolling into the new Promag W800 now. So yeah, as we mentioned earlier, it's our brand new battery powered flow meter. It comes with heartbeat technology, which we'll cover a little bit further on, and then a whole suite of IoT connectivity use cases as well. We've actually had the Promag W800 as a battery powered flow meter for quite a long time, and this iteration now is to replace one-to-one the older version. So if you've ever used one of our older flow meters, this particular new one now is same length, same features, that sort of thing, but just some added functionality just in case you've seen the name before. So some of the key aspects that the flow meter is going to have in it. So heartbeat technology, again, which we'll cover off, but the major function here will be around verification, so the ability to health check and verify the meter in situ. It's going to come with a data logger, so anywhere between 10,000 to 50,000 data points is the ability here. The display, this TFT display, is sort of an energy saving, battery saving function where it goes to sleep, and then the way to wake it up would just be to hold your finger on it and it'll wake up. So it's got a display function. Output wise, we're talking pulse and Modbus from a standard perspective, and then we roll into wireless, cellular radio solutions. Excuse me. All interface to the Flowmeter is done by Bluetooth, and that's using our SmartBlue app. So gone are the days where you need, say, a serial connection, or it could be an infrared dongle with some software and a PC. It's all done now via Bluetooth and the SmartBlue app, and that can be done on your phone or a tablet. Real-time clock that's just to maintain the time and date and that sort of thing for data logging. Large varied pipe sizes, so up to 1200 will eventually be available. There's an external pressure sensor. So this is not a pressure sensor that would be integral to the meter in terms of being mounted through the spool piece of the tube. It's actually an external sensor. So the idea there, that can be installed in the line up or downstream of the Flowmeter, and the wiring of that would run back to the Flowmeter, and the Flowmeter power the sensor, and then the pressure measurement be made available for output, be it on Modbus or via radio as an example. So further to that, we've got connectivity measurement as well, if you're inclined to need to measure connectivity of the fluid. I mentioned earlier, 0DN is an availability that's with the Promag W800 as well. So in those applications where we've got some tight spaces that your traditional 5 times pipe diameter upstream is not going to allow for, 0DN is available. And the last piece there is fully IP rated for those applications where you're bearing underground or you're in pits where they can be flooded and things like that. So IP68 fully available as well. So that's a bit of a high level snapshot on what the W800 is going to have in it from a functionality perspective. And this is a bit of a breakdown for you on the separation between, I guess, basic or standard and advanced. So we're going to have a standard version, which is purely going to be pulse and Modbus, which then you'd use this for purely just say for visual indication of the flow if you don't need the outputs. If you wanted to get the readings back to, say, a cloud solution or a SCADA system, you could use the pulse and Modbus outputs, and that could feed to, say, an RTU. So that's one option there. And then the second option is our advanced version, which is going to have the cellular capability, and then Taylor will cover off the different use cases that are available in that space a little bit later on. But that gives you an idea of the separation and where we're going with the W800 around standard and advanced there. So we mentioned earlier the Bluetooth functionality and using our SmartBlue app. So as I mentioned, everything done via Bluetooth and SmartBlue. So no dongles, no software, no PCs required at all, and that's everything from setup to verification. We have embedded as well this commissioning wizard, which makes commissioning and programming time a lot quicker and easier, and that's that's the answer to the poll question earlier as to what's most important, or one of the most important features. So I'll quickly show you how this looks. So this is basically connecting to the Flowmeter via Bluetooth. Here's the menu structure. We go into commissioning, and then we roll through a guided wizard. So this is sort of Flowmeter information. Here you'd adjust your flow units for instantaneous flow and total, and then we've got 3 totalizers where you can adjust the totalizer units as well, what direction. So we go through this, some measuring modes, we're in an empty pipe, things like that, and then what you want to do with your pulse output if you're using the pulse, so your pulse frequency and what the pulse represents. And we've got up to 3 pulse outputs. The display, what you want to see on the display, the date and time, and then we finish off at the end, and then you can download the setup, as a file for later viewing and things like that. So very, very simple setup, and then that can be done in literally a couple of minutes. So there's a lot of time savings and cost savings with the use of the Bluetooth app there for commissioning. We're stuck here again. All right, so the next part here is going to be about verification. So if you're not familiar with Endress+Hauser and our philosophy around diagnostics and verification, that we refer to this as heartbeat technology. So under this concept, we have 3 pillars. We have diagnostics, we have verification, and we have monitoring. So diagnostics is all about exactly that, diagnostics. It's all about meter health, meter status, and the meter continually checking its own diagnostics. So we have this, I guess, this symbol system here, and this is all under NEMUA, the NE 107 standard, which is the international standard for instrument diagnostics and this sort of thing. So here's an example that, you know, our Flowmeter is in good health. Maybe we need some maintenance, or the extreme instance here is that you know, we've got a catastrophic failure and we need to do something. So there's continuous feedback from our diagnostics in our Flowmeter. The verification piece here. So this is a guided, it's a guided procedure for testing and health checking, with the end a fully traceable documented certificate saying that the meter is in good working order or not. So this is really referencing diagnostic values, checking threshold values, and then pass or failing a meter that it's in good working order or not. So we've got an example later on to show you how that looks. And heartbeat monitoring is all about using those diagnostics for preventive maintenance. So you might be monitoring, for example, in a Flowmeter, impedance values, resistance values as an example, and then continually monitoring those and checking to see if they move or drift over time with early warning signs, and maybe you need to do some maintenance. So you can use heartbeat diagnostics for that function as well. So traditional verification was typically done on Flowmeters using external tools. So here you have an external verification tool, and each vendor or manufacturer of Flowmeters have these for sure. And then you'd need to connect to the Flowmeter externally here, open up housings. Then you'd need to have some software available to be able to download the certificate and the test results. So this process could take, you know, up to 45 minutes. These days with heartbeat verification, we're talking about verification that can be done, you know, up to, you know, as little as 5 minutes, and in some cases even quicker than that. So we don't need any tools anymore. With the W800, for example, it can even be done remotely over cellular if that's a requirement. So even going to the field may not be a requirement. It can be done without, you know, interrupting the process as well. So it's quite an advancement in the way verification of Flowmetering can be done. And as I mentioned, you get a full documented report at the conclusion of the verification process here. So, you know, meter details, you get all the test results of what was checked with a pass or fail. So you have this color coding, you know, tick or cross basically, and then what the threshold diagnostic values were, and making sure they pass. So conversely, if you get a failed verification, these results can assist with, I guess, with fault finding and knowing what's wrong with the meter as well. So it's not just about, a pass on the verification. You can also use for maintenance. So and this appeases, you know, compliance and also your maintenance regimes as well. So I'll just give you a quick little look at how actually heartbeat verification is done on the Promag W800 using Bluetooth. Again, it can be done remotely via Natillion, our cloud solution, but I was going to show you how it's done on the Bluetooth app. So I'll just quickly play here to give you an idea. So again, we connect to the Flowmeter via Bluetooth. And this is sort of the landing page or the home page of the Flowmeter. Menu structure, so we go to diagnostics, perform a verification. Here you put in some details around, you know, who the operator name is and location, and then we start a verification. This is where the Flowmeter will do its self-check against all those diagnostics we mentioned earlier. And you get a progress bar here to tell you how far along the verification it is. And then in the end, you get a pass or fail. So this example here, it's actually failed, the Flowmeter. And then from there, you can generate a heartbeat verification report for viewing, for being able to use it for fault finding, and then again for appeasing compliance and maintenance activities there. And you can download that as a full-blown certificate. So that's heartbeat verification in the W800. Again, no software is required, no opening of the housing. It's all just done by Bluetooth and the Smart Blue app. So quite and that was literally done in a minute. So very, very quick process as well. I mentioned at the beginning there electromagnetic flow meting in general and some of the challenges around potential challenges around accuracy. And a way we can overcome this in the new W800 is this adaptive intelligent mode. So I mentioned earlier about how a traditional battery powered flow meter works with taking a measurement every 15 seconds. And if we have fluctuating flow here, there's potential that we can miss some of this flow, and then you have inaccurate measurement. So what this adaptive intelligence mode does by activating is it'll actually pick up that we actually have some spikes in the flows, or some in comparison to just a regular flow rate, and then it'll actually automatically increase the measuring frequency. So from, say, an example, say from 15 seconds down to 5 seconds, so we're not missing those spikes in flow and then not having inaccurate measurements. So the unfortunate byproduct of that is that, yeah, because you are measuring more frequently, that it will impact battery performance and battery life. So it depends on the application whether you use this function or not, but this is one way we can come across one of those challenges we see with electromagnetic battery-powered flow meters. So on batteries, so this is a key question that's always what we always get asked on, how long does a battery last? What's the performance of the battery like? So we've got the ability to have an external battery with our flow meter as an example, or internal batteries, as we mentioned earlier. To give an example, an external battery would last up to 15 years, depending on the setup and what you're using it for. But on our website, we have this program called Applicator, where you can actually go in and under the sizing section here, this is an example over here in the video, just put some application detail in here. So measuring water as an example. We're going to select the Promag W800 as our flow meter of choice. And we're going to just put some application detail in here, just around flow. And so you can always obviously use this also for sizing, so making sure the flow meter is suitable for the application and pipe size. And then with this here, we get an estimated battery life function. So here, this is where you'd put in, well, how many battery packs do I have? Do I have one, or do I have two? Do I have an internal, external battery pack? The size of the flow meter, things like, the output that you're using. Am I using cellular, or am I using Modbus? The measurement frequency, things like how often am I logging? All those factors will impact the performance of the battery and lifetime of the battery. So we can put all that data in here. You can see an example here, and you can see the actual estimated battery life function here changing as we change things like measurement frequency and the like. So this is a nice tool, and this we can actually make this link available to you after the webinar if you're interested in having a look and having a bit of a play there. So that's the Applicator program on our website, and that's how we'd calculate batteries. So yeah, for sure we've got standard battery lifetime specs, in our information, but this is a nice tool that can be used to, I guess, verify, your application. Sorry, I'm just waiting for the next page to roll over. So I'd just like to hand over to Taylor now, and Taylor's going to cover off with you the IoT connectivity functionality that we have in the W800.
Thanks very much, Scott. So we had a lot of questions coming in the pre-webinar information that we sent out around how to get the information and the data from the Promag W800 into your system so you can use it. So I just want to briefly touch upon how you can do that. And first of all, I want to discuss around the cell radio that comes with the Promag W800. Now, in this case, the Promag W800 cell radio will work if the network that it's using is 3GPP release 13 or higher, and supports LTE Cat M1 or MB1, which is 4G NB IoT. Now, these networks are slightly different to what you use on your mobile phone, but the good news is that because of the frequency that it uses, the range is longer or further than it would be for normal 4G or LTE that you use for your mobile phone. So on the right-hand side, you can see an example of the map coverage of NB IoT by Telstra. This is a good example that you can use to see if the coverage is where your site is. So you can go check out the coverage using that URL over there on the slide, or you can just Google NB-IoT Telstra coverage, and that will give you a good indication if it's available on your site. We find that like more than 99% of the population is really covered by the IoT network here, so it's quite flexible. How we use the cell radio, I'll explain in a few more slides where we go through different use cases. And of course, if you don't have access to the NB-IoT network, then you can also use your own network depending on what frequency it supports as well. So if you want further information about that specific application, definitely let me know. Now I'll go through the specific use cases. In this example, the first one that you see on your slide on the left-hand side is where the Promag W800 is just being acted as a self-powered device without a cell connection. The output is wired via pulses or Modbus RS485, and we can use this Modbus output to connect to a site standard gateway that you might have as an alternative to the cell radio. You can also configure the pulse output in the SmartBlue app that Scott showed earlier. And you can see the use cases from 2 onwards use the cell radio. In use case 2, which we think is probably going to be the most popular one by most of our customers, is around using your own existing server infrastructure that you have on site. So we provide the client and the server that you can download and then set up your own connectivity solution. We use message queuing telemetry transfer, or MQTT, and that, if you don't know, is a lightweight publish subscribe network protocol that transports the messages between devices. So this protocol normally runs over TCP/IP. However, any network protocol that provides ordered, lossless, bidirectional connections can support MQTT, so it makes it really flexible. OPC UA data has more than 100 device parameters that you can use for different device insights, and that can really be a flexible way to use the data that you get from the device and bring it into your own existing infrastructure. For the next use case, which is use case number 3, this is where you can use OPC UA, and we provide the infrastructure to connect the device. So you're using our cloud system, and we call this Natillion. So what you need to do is to create a Natillion account, and then you just use our Natillion add-on service called Connect, and then you onboard the device. So this looks like this video here that I'll show. And you can either do it for free via our Natillion Value account, as I've shown on this slide here. And you can see that the asset details are on through a web browser, and you get all the information through there. Or alternatively, you can do it via a programmed version, and we can use a REST API to access more data and execute more actions. So the communication chain in this example is the Promag 800 sends MQTT data to Natillion, where there's a connectivity server that converts this data to information that can be accessed via API or via OPC server that I just showed. In use case number 4, this is where we use Natillion applications from Endress+Hauser to be able to use the information that you have on your Promag W800. So in this case, we have apps that can be viewed on your mobile device that have dashboards. You can get some alerts and notifications as well. You can track measurements over time if you wanted to have that information in a cloud solution. You can export the data in CSV format. And you can also do some basic asset management functions and commission it via the systems as well. So if that's an alternative that you're investigating, let us know. We can show you the capability. Or you can also go to natillion.endress.com, and then I'll show you all that information as well. And finally, the 5th use case is around Natillion Water Network Insights. Now, this is a full customizable solution where we get improved HMI visualization of the information. You can use it for heartbeat verifications as well to maintain the compliance of the Promag W800 in the field. You can get more advanced alerts and notifications via SMS or email if you need to send that to a distribution list, or multiple SMSs, that's possible as well. You can trend and report on the data. You can easily also integrate third-party sensors and pumps and valves to the system. And you can also incorporate data sources from external areas like weather. You can do improved asset management functions, and you can also expand it if you require. So we can make custom solutions as well for you if you guys want. So I've shown the 5 different use cases that you might have on site, and I would just like to ask you a question now. What would the device connectivity scenario that you would most likely use in your operation? So this will help us also help you when we're giving you more information around the different use cases. So we'll use it just as a self-powered device. Will you implement it with your own OPC UA server infrastructure and bring that information into your own system? Would you use us as the infrastructure, use Natillion with the apps, or would you use the full solution of Natillion Water Network Insights? All right, I'll just wait a few more seconds until people have voted. Yeah, for this one, you can only choose one option. All right, a couple more seconds. We've got 2/3 of the people now voted. Okay, all right, I think that's about it. So we'll share the results for this one. So half of you will use the OPC UA option. Yep, that's what we thought and would be most popular. Interestingly, a quarter of you will just use it as a simple battery-powered sensor with local connectivity, or using plugging into your own gateway or some other communication via Modbus. That's also awesome. And then the rest of you split maybe between 7 and 10% around the other solutions. Excellent. So what we're going to be jumping into now is we've discussed the device. We've discussed how to bring it into your system and use the data. And now we're going to be talking about different applications. And I'll be kicking off in the mining sector. So as you can see on the list in front of you, there's lots of different applications where you can use a remote process water meter without any power. So from water distribution to groundwater extraction, anywhere really where there's it's too expensive or too hard to bring power to the device, and you want to communicate it into your system, like return water from tailings dams or toll metering from different sites, leak detection possibilities as well, if you have to make sure that your water on site isn't able to be, if it does leak, it has to be detected quickly and effectively. That's where the notifications come into it, and to be quite an effective leak detection system. Another example as well that I can show you on the next slide is different examples here. So you've got remote water distribution on the first picture there. If you had a type of skid, or if you required process water metering without any mains power, that could be an option. If you had return water or clarified tailings with leak detection, then that would be an option. And then of course, if your operation has some type of heap leaching, dust suppression, or evaporation fields out in the open cut area, then you can also use it for that. I'll hand over to Scott now. He's going to talk about the water wastewater applications.
Thanks, Taylor. Yeah, so like mining, let's go back one screen. Sorry about that. There we go. So like mining, there's many an application in the water and wastewater industry, and there's you can see a lot there. But basically, anywhere we have a pipeline where we've got potable water that needs to be measured. So lots of drinking water applications, distribution lines, water distribution. There's zone metering and district metering, where then we're looking at leak detection as an example. So looking at flows and pressure to determine do we have any leaks in our network. I guess groundwater extraction, so bores and things like this, and then also can be used for revenue. And another interesting application there is in sort of buildings and that sort of thing, where you have building and fire services. So this is another application that these can be used for from a water perspective. When we go into, I guess, non-urban, irrigation, is a key application for battery-powered electromagnetic flow meters. So channel offtakes and these sorts of things, and revenue metering is big application areas for the W800 for sure. And I guess further to that, a lag on my end, apologies. Here we go. So just some of those typical applications. So yeah, basically anywhere you're going to have the need to measure water in a pipe where you don't have power, connectivity, these sorts of things. So very varied applications there in water distribution and alike. We've got an example here in ground and surface water extraction, as I mentioned earlier. An example here of a fire services application. So in a building environment. So very varied applications. And then another one here, and going back to what I mentioned earlier about if you've got space constraints, so you don't have enough straight pipe after, be it a valve or a bend or something like this, there's also the ability to have this 0DN option on the W800 installed in applications that we don't have the room as such. So there's some water and wastewater application examples for you. So yeah, so really appreciate the attention there and the feedback in the polls. It's been great seeing your thoughts there. So now we're ready to look at some questions. So there's actually some questions here that I've got here. So Ken's here. A few questions. So the size of the battery pack, Ken. So this is around the external batteries. This is about 150 by about 200 millimeters is the external battery pack, to give you an idea of the size of the external battery pack. Ken's got another question here about the temperature, the ambient temperature that the flow meter can take. So this is 60 degrees. So yeah, it certainly gets hot in Marble Bar, is what Ken's saying there. So he's saying it can get up to 50 degrees. So yeah, so based off that, we can use the W800 just. Battery life, another question from Ken. Yes, you can get the battery life outputted, and the current battery capacity can be outputted as a value, and this can be done on via wireless connectivity. It can be done on Modbus as an example, so that's certainly available as well. So Taylor, is that he's got a few questions about MQTT. Tackle those.
Yep. So I think Zahir asks around the different versions of the protocol and if they can connect the device into any broker, and if we can onboard the device into any IoT cloud hub as well using MQTT. So yeah, so I can give you, what we'll do is we'll give a bit more information around how it can actually connect via MQTT after this webinar, and which protocols it uses, but as I mentioned before, it's quite easy to do it if you have an IoT team on site that's familiar with MQTT protocols, and particularly if you've done it before as well, with different devices as well. So we'll give you a bit more information after the webinar. We've got another question as well. This one's from Daniel around, do we do similar wireless setups for other sensors? And that's definitely something that we can investigate as well. So the good thing with Endress+Hauser is we can create a solution for your measuring application. So just because we have, I mean, the Promag W800 is a nice wireless flow device, but we can also create some type of other solution depending on your measuring needs as well. I think there's another one for you, Scott.
Yeah, Dan's asked a question here about the accuracy at low flow. So this is a difficult one to answer, Dan, because it depends on the flow rate, the flow velocity, and the pipe size there. So we've got the ability in that applicator tool that was presented earlier to put the flow rates in and the pipe size, and then from there we can actually get a value there. So we can there's certainly a link to applicator later on, or we can certainly send you some information there if you'd like to send through you know, I guess your flow rate information, then we can look at the flow rate sizing for you for sure. Yeah. Any others in there, Taylor? We have
yep, there's one by Tyler. So he asks what the cybersecurity requirements are in place with the platforms. So for our own ones, the Natillion, the cybersecurity is very high actually. In fact, it's third-party verified by Eurostar. So we've got a 4-star third-party verification for that, which is the highest out of any industrial field instrumentation provider. And we can give you a bit more details on cybersecurity, but depending on what you're specifically after, but I can assure you that that's something that is implemented in the design of our cloud solution systems as well.
Got it from Blake. So Blake's asked about leak detection. So certainly, yeah, leak detection is a relatively standard application for battery powered electromagnetic flowmeters. So with flow and pressure as the key variables there. So I think Blake, after this, we've certainly got some examples there I can share with you that'll give you some more detail there, and we can send that to the wider audience as well for sure. So yeah.
I got a question from Tom here around, is the cloud solution hosted in Australia? So the Natillion one it depends, I guess, on which one you're talking about, but the Natillion one where it's stored is not, but if you need a cloud solution hosted in Australia, we can do that for you. Just let us know, and that's something that we can create a solution for, and we have done it before as well.
Good. This one from Daniel Taylor. So Daniel's just up communicating to the Flowmeter wirelessly. You know, can you communicate to Flowmeter to make changes to it if you're not on a cloud solution or using the cellular version? So then be in the proximity of the Flowmeter, so up to sort of 10 meters, and to use the Smart Blue app using Bluetooth to be able to do that. So if you're on the cellular network and using, say, the Natillion platform, for sure you can go in remotely and get readings, that sort of thing. But to make changes, it's got to be done via the Smart Blue app. Correct.
Yeah. If anyone is interested about what the Smart Blue app looks like with the Promag W800, if you do download it and that QR code is on your slide right now, you can go onto the demo side, and there's a lot of different devices that are in demo mode on the Smart Blue app. So even though you're not near a specific device, you can see a lot of the functionality in the Smart Blue app, and you can have a look around, which is quite cool. I think we've got a question around are the batteries rechargeable or not from Anthony. So the batteries, not. If you want to extend the battery life, you can talk to us about some other solutions around that aspect as well. If you want to use solar panels or something like that, that's a solution that we can create for you. But it might be best to talk about your specific requirements offline.
There's one here from Anthony. I'll tackle that one, Taylor. So Anthony's asked data logging. So that's certainly a key function of the W800. You can certainly data log pressure and connectivity, Anthony, for sure. So that's all available there, and then those values you can download in the log file. So together with flow as well, for sure. Your question there about can you have other variables, be it vibration and say other things. There's no facility to have another device or another input to the Flowmeter for other devices. So you can log what's in the Flowmeter, which is going to be flow, and there is actually temperature available there. There's connectivity, there's pressure as well, and obviously all your flow readings. So it's available there, but not an external device like a vibration sensor or something like that.
I think we might have only time for one more question. There's one from Reba, I think, asking around the reduction of the energy consumption, and because I guess choosing the actual flow rate or volume depending on that. So I think she's speaking about the intelligent adaptation. And Scott, you might want to talk a bit more or jump in as well as I go on trying to explain it. But it's around if there is a large change of flow rate, then the measurement will be more often. If the flow rate is steady, which we would probably think that a lot of the dewatering applications or water management applications out there, there's a long period of time where the flow rate is quite steady. This means that the energy that is being captured by the recording of all those values, that time interval is extended, and that is the intelligent adaptation. So therefore, every time there's a recording of the information, then it's reduces the battery of the energy consumption. Did I capture that correctly, Scott?
Pretty much in a nutshell. Yeah, that's good.
Excellent.
No worries.
Right, I think that might be all the time we've got at the moment. If we didn't get to your questions, we'll definitely be following up afterwards. And if you've got any other further questions after today's session, just get in contact with one of us and we'll be able to answer the question.
Well, thanks everybody for attending. Thanks for your time.
See you at the next one.